Good evening and welcome back to another geometry lesson. Today we are in section 3-8 and it's called Parallel and Perpendicular Lines. We are going to be doing a lot more algebra today again, and it might feel a little bit like it's not geometry, but I promise that they are closely related. So by the end of class today, or by the end of the video, I should say, I would like for you to be able to write equations of parallel and perpendicular lines when given the first line equation. Now, we did talk about some of this stuff in yesterday's notes, but we're just going to kind of recap again because I really want to make sure that it's sticking with you. So first of all, the slope of a line is often denoted by the letter M, and the equation for that, or I should say formula, is going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1, and that's rise over run. So that is the formula for slope. Then we have point slope form, and that involves a point and a slope, just like it would imply. So that is going to be y minus y1 is equal to m parentheses x minus x1, where m is equal to the slope and x1, y1 is equal to a coordinate on the line. And finally, we have slope-intercept form, which is going to be y is equal to mx plus b. M is still slope, and b is equal to the y-intercept. Now here we have a summary of different types of slopes. And as you can see, we have a line going uphill, a line going downhill, a line going flat, and a line straight up and down. So we can kind of identify in general what types of slopes these are. So if it's going uphill, that is a positive slope. If it's going downhill, it's going to be negative. If it's going completely flat, like not up or down or anything, that is a zero slope. And then if it's going straight up and down, that is called undefined. Hopefully all of that is review for you today. So let's start putting our slope formula into action with our first example. And it says, calculate the slope of each line using the slope formula and check your work by counting on the graph. So we are going to calculate the slope of each of these lines. And what I'm first going to do, I'm just going to list what the coordinates are. So I'm going to say A is equal to, and B is equal to, A and C, A and D, and C and D. So I'm just going to list the coordinates real fast because then I won't have to keep going over and rereading it. So A is right here, and it is at the coordinate -2, 1, 2, 3, 4, 5, 6, 7, -2, 7. So I'm just going to put that next to all of the A's so I have it ready. And then I'm going to do B. B is at the coordinate 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. It is at 3, 7. Point C is at 1, 2, 3, 4, 1, 2. So 4, 2, and 4, 2. And then I need to find point D, that's at -2, 1. So in order to calculate slope, I have to have two coordinates, and I just went ahead and wrote them all out so that I wouldn't have to keep looking on the graph. So now what I'm going to do, I'm just going to start with problem A, and I'm finding the slope of line AB, which is this guy right here. So I'm going to label my coordinates x1, y1, x2, y2. And then I'm going to fill into my formula, and I'll write it over here again for us. y2 minus y1 over x2 minus x1. So that's going to be 7 minus 7 over 3 minus negative 2. So 7 minus 7 is equal to 0, and 3 minus negative 2 is equal to 3 plus positive 2, or over 5. But 0 divided by anything is still 0, so that is my solution. If I want to check this with my graph, here is my line AB. It is flat, and up here in my table it says that a flat line has a slope of 0, so that checks out. It's correct. Looking at problem B, I have line AC, which is this guy right here that I want to calculate. So once again, I'm going to substitute everything into my slope formula. I need to label my x1, y1 stuff though. x1, y1, x2, y2. That gets me 2 minus 7 over 4 minus negative 2. 2 minus 7 is equal to negative 5. And 4 minus negative 2 is equal to 6. So I now have a slope of negative 5 over 6. Remember, that's rise over run. So let's go down 5 from A and over 6 and see if that gets us on point C. So down 5, 1, 2, 3, 4, 5, and over 6, 1, 2, 3, 4, 5, 6. Yes, so I know that I'm correct because they both fall on the same line, and I counted it, and that is how I got from one point to the next. Moving on to problem C. I'm going to label my x1, y1 stuff again. And I'm just going to start filling in my formula. So I have 1 minus 7 over negative 2 minus negative 2. 1 minus 7 is negative 6, and negative 2 minus negative 2 is actually plus a positive, which gets me 0. Now this is an issue because I cannot divide by 0, so that means this is going to be undefined. If I look at my line AD, notice how it goes straight up and down, and that does correspond with my table up here that says a straight up and down line is undefined, so I know that I'm correct. And finally, example C, I have point C and point D. I'm substituting it into my slope formula right here, and I will mark my x1, y1, x2, y2 for you. I have 1 minus 2 over negative 2 minus 4. 1 minus 2 is negative 1. And negative 2 minus 4 is going to equal negative 6. These do cancel each other out, the negatives do, so this is actually positive 1/6, and there is my slope. So let's start at point D and see if I can go up 1 over 6 and get to C. Go up 1 and then over 6, 1, 2, 3, 4, 5, 6. That does get me to C, so I am correct. So that was hopefully just some review for you about calculating slope. Now we have a word problem involving slope. It says, Justin is driving from his home to his college dormitory. At 4 o'clock p.m., he is 260 miles from his home. At 7 o'clock p.m., he is 455 miles from his home. Using the graph of the line that represents Justin's distance from home at a given time, find the slope and explain what it represents. So here I have how far away Justin is from his house after 4 hours of driving, and then after 7, or I guess at 4 o'clock, and then at 7 o'clock. So my coordinates here are x1, y1, x2, y2, or however you really want to label it. I'm going to do x1, y1, x2, y2 like this so that my I actually did it backwards the way I wanted it. I'm going to do 2 and 2 and 1 and 1. There we go. So then I can have positive numbers. I need to calculate the slope, so that's y2 minus y1 over x2 minus x1. So that's going to be 455 minus 260 over 7 minus 3. When I take 455 minus 260, I get 195 over, and then 7 minus 3 is 4. So there's my slope. But what does this represent? Well, notice on the bottom axis is time, and on the vertical axis is distance. So this slope is letting us know how far or how quickly Justin is driving to his dorm. So the slope represents how quickly Justin is driving to his dorm. Or leaving his house. So this is very similar to what we did on the previous side and in yesterday's notes. It's just with a word problem now. Okay, looking at example 3, it says graph each line. So line L is in slope-intercept form, which means this 1/2 is equal to the slope, and the -1 is the y-intercept. So what I'm going to do here, I am going to go to my y-intercept, which is at -1, and then I'm going to count up 1 over 2, up 1 over 2, because remember slope is rise over run. So up 1 over 2, up 1 over 2, up 1 over 2. So here is, I'll do my best to draw a straight line. Here is line A, just for, or I guess I could call it line L because it's called line L. Let's look at this one. This is in the form y minus y sub 1 is equal to m multiplied by x minus x sub 1. So it's in point slope form. So this is my slope, and my x1, y1 is equal to -4, 2. Now you might be wondering, how did I get -4? Because this says positive. My slope, or not my slope, sorry, my formula is y minus y sub 1 is equal to -2/3 x minus x sub 1. This positive is opposite from this negative. So I need to actually say, if this were to be in the exact order, it would say minus -4, and that's how I would get that negative. So now I have my coordinate. I'm going to go back 4, 1, 2, 3, 4, up 2, 1, 2. And then I'm going to use my slope of rise over run, and I'm going to go down 2 over 3. Down 2 over 3. Down 2, 1, 2 over 3. And once again, I'm going to do my best to connect these dots. And that is line M, so I'm going to label it like that. Next, I have the equation y equals x. Now, if you have an equation that seems to confuse you a little bit, my suggestion to you is to build a table. So I'm going to make a table of values, and I'm going to say just a bunch of values that x could equal. So maybe 0, 1, 4, and -2. Well, if x equals 0, then I could plug it in, and that would mean y equals 0. So if x equals 0, then y equals 0. If x equals 1, then y equals 1. If x equals 4, then y equals 4, and so on and so forth. So whatever one value is, the other must match because of the way this formula or equation is written. So let's plot a few of those. 0, 0, 1, 1, 4, 4, -2, -2. Hopefully you're noticing, whoops, bumping the camera. There we go. We have this line forming right here, and that is line N. I have one more line that I want to graph. Line P, and it says x is equal to -6. Okay, if x equals -6, then y can equal anything we want. So let's just list some x values or some y values with x being -6. So x is -6, y could be 0. X could be -6 and y could be 3. X could be -6 and y is -1. Let's plot those and see what it looks like. So -6, 0, -6, 3, 1, 2, 3, -6, -1. Notice how all of these dots are forming a straight line up and down. So that's going to be the image that I draw. And this is line P. And there I have it. I have graphed all 4 of my lines in my coordinate plane. So I'm done with that example. In example 4, it says, what is the equation of the line on the graph in both point-slope form and slope-intercept form? So let's write out my point-slope and slope-intercept form one more time. It is y equals mx plus b, and y minus y sub 1 is equal to m multiplied by x minus x sub 1. Let's find and calculate some things in this graph real fast. Can we easily find the y-intercept? Yes, right here. So I am going to mark this, and I'm going to say y-intercept at, and that is at 0, 2. Can I calculate the slope? Yes, I can. I can count from 2 points, and that's going to get me my slope. So if I were to go from point -1, 4 to the y-intercept right here, that would be down 2 over 1, or -2. So I'm going to say m is equal to -2, and I'm just going to kind of put a little cloud around it because that's important information for when we're writing our formulas. So now let's write out our equations. I have y equals mx plus b, so I'm going to have y equals m. I'm going to substitute in -2 plus b, and b represents the y-intercept, so that's going to be 2. And I'm done. But I also need this in point slope, so I'm going to use this formula, and it's y minus y1. Well, which one is y1? It doesn't matter, you can choose whatever you want. I'm just going to choose that this guy down here is x1, y1. If you were to have chosen this one, that's okay. So y minus y1 is y minus -2 is equal to m, or the slope, -2, parentheses, x minus x sub 1, or 2. So now I have 2 ways to write the same equation for this line right here. We only have a couple more examples to this note page or this note section, and then we are done. So it says, what are the equations of the vertical and horizontal lines that pass through the point to -3. All right. I'm just going to remind you from yesterday. A vertical line equals or is x equals a number. A horizontal line is y equals a number. Now, if we want these lines to go specifically through the point to -3, it's going to be as simple as this. I'm going to say x equals 2 and y equals -3. Because x must, or the lines must go through this point, so x must be the x value and y must be the y value. So I'm going to have x equals 2 and y equals -3. And there's my two equations. So that was kind of a speedy example for you. In my next example, it says find an equation of a line parallel to y equals -3x minus 5 that contains the point -1, 8. So, here is my suggestion for you. When you see something that it wants you to make parallel, you automatically go towards the slope. Slope is equal to -3. So I know that my new line must also have a slope of -3 because parallel lines have equal slopes. That's important. Parallel lines have equal slopes. I'm actually going to kind of put a graphic around that so it really sticks out for you. We also want this line to go through this point right here. If you have the slope, which we do, and we have a point, which we do, we should use point slope form. So point slope form is y minus y sub 1 is equal to m multiplied by x minus x sub 1. Let's fill that in. Y minus y sub 1, or y minus 8, because the 8 is in the y value, or in the y value spot. So y minus 8 is equal to m, the slope is -3, parentheses, x minus x sub 1 is -1 because the -1 is in the x values spot. I'll go ahead and change that to a positive, so that gets me y minus 8 is equal to -3, x plus 1. Because it didn't tell us to put it in a particular form, I'm going to leave it like that because that is an equation of a line, and it didn't tell us to put it in standard form or slope-intercept form. So that's fine the way it is. As I like to say, work smarter, not harder. For my last example, it says find an equation of a line perpendicular to y equals -2x minus 8 that contains the point 4, 4. Now, we talked about this yesterday. Perpendicular lines have opposite reciprocal slopes. I'm going to write that out for you now. Perpendicular, the upside down T stands for perpendicular. Perpendicular lines have opposite reciprocal slopes. That is very important as well, so I'm going to hopefully draw your attention to it. And let's just do a couple examples over here to the side of what opposite reciprocals are real fast. So if your slope was 3/4, an opposite reciprocal would be -4/3. The positive went to a negative and the fraction flipped upside down. If your slope was -2/7, The opposite reciprocal would be positive 7/2. If your slope was, I don't know, 5, the opposite reciprocal would be negative 1/5. Because I changed a positive to a negative, and remember that every whole number is actually over an invisible 1. So that's how we got the 1 for the 1/5. So those are just a couple examples of opposite reciprocals, just so you could see them over to the side. So now let's do this problem. I want a line perpendicular to this guy. Well, if the slope is equal to -2, the opposite reciprocal of -2 is going to be positive 1/2. So my new slope is equal to 1/2. And then I have my coordinates right there. Because I have a point and I have a slope, I'm once again going to use y minus y sub 1 is equal to m parentheses x minus x sub 1. So let's do it. Y minus y sub 1, that's going to be y minus 4, is equal to m, or 1/2, parentheses, x minus 4. And I'm leaving it like that because it didn't tell me to put it in a particular format. That is everything that we're going to be covering for this chapter. Please be sure to bring your questions to me tomorrow in class, and I look forward to seeing you soon. Bye.